Right. You see, we have a big organization. Even though the organization is one, we got many networks, sorry, many departments. Why? Because in an organization, we have different group of people with various roles, different roles. All don't do the same role. Few groups are called as HR role. Few groups are called as sales role. We have various roles. Depending on the role, we group them and we call it as a department. So in an organization, we need groups. If you have groups, even in network, you need to have group. The reason why you have sales, HR, you want to keep them separate. Even though they all work for one organization, you do not want a front office guy looking into the Excel sheet of the HR. Strictly, you don't like. So you create a group and you isolate them. There is a policy which is isolating them, even though they belong to one company, one organization. Now, when you have a common network, then your policy cannot be achieved. Physically, I no need to go to the HR room. Through network, I can easily get into HR's computer. You see? So we have to isolate the department-wise our network. Our network needs to be chopped into pieces. That is what we do when we do subnetting. If you say in my organization we use 10 network, you're right. Of course you use 10 network. But the 10 network of sales and 10 network of production and the 10 network of HR are not the same. Though they belong to 10 network, they are logically isolated from one another. Layer 3 separates them. Network layer separates them. They belong to different network because we have subnetted this one network into multiple subnets, and we give one piece, one subnet to sales, another subnet to HR, another subnet to production, another subnet to admin. Earlier it was only one network. When you have this as a subnet mask, this is only one 10 network. It is not subnetted. It is not subnetted. But if someone writes 255.255.00, then you cannot call this as a network. 10 is not a network. 10.0 is the network. It's two different things. When you write this subnet mask, it is just a 10 network. But when you write 255.255.00, it is 10.0 network. It is no more class A. It is subnetted. It's no more class A, it is subnetted. So you might have gotten a clue how we do subnetting. How we do subnetting, we take some host bit. Like here I have taken 8 host bit. Usually the second octet is not host. Sorry, it is host. The second octet is host. If it is class full, this is host bit. These 3 are host bit if it is class A. But when I write mask like this, I have borrowed 8 bits from the host to be considered as network bit. Earlier we got 8-bit, see, 255. Additionally, I got another 8-bit. In that 8-bit, I have put all the 8-bit as 0. That's why you got 10.0. If I would have said 10.00000001, and if the mask is this, then it is 10.1 network. This is network. 10.0 for the same subnet. This is 10.0 network. This is 10.1 network. They are not same. They are not same. Because the mask is 16-bit mask. Even the second octet is network. So I have taken 8-bit from the second octet, and I am able to have new networks of same 10 network. 10 network, but it is not simply 10 network, it is 10.0 network, 10.1 network, 10.2. I can go up to 10.255 with the 80-bit. This is not one network now. Earlier, when this was the subnet mask, this is just one network. But when this is the subnet mask, this is one network, this is another network, because this is 10.0 network, this is 10.1 network. They are not the same. I can go like this, 10.2, 10.3 up to 10.255. So 255 subnets, 255 departments I can use. For each department I can give one subnet. So one thing we have learned now, subnetting is by borrowing host bit for network. We borrow some host bit for creating subnets or creating more networks out of that same 10 network. See? So subnetting is breaking down a network into multiple networks. But when I say breakdown, don't think that this from this 10 you take 2-bit out. No. See, the 10 should be always same. This is what I mean breaking down. I have broken down the host bits. Out of 24-bit, now I got only 16-bit for host, because 8-bit I have already given for networking, for subnetting. So subnetting is borrowing some host bits so that you can have subcategories of the network, subnets of the network. Okay, now what is next? Before we get into subnetting, I would like to give you a small exercise. Afterwards, we can go deep into it. You need to answer this. What class this belongs to, and what is the default subnet mask? You know what is DSM? default subnet mask. Because I don't have place, I'm writing like this. And what will be the first host IP, or what is the first computer's IP in the subnet? And what will be the last host ID or IP? And what will be the broadcast IP? What is broadcast IP? The address which can take your message to everyone in the network. See, in 10 network, I have 24 bits. In 24 bit, how many IP address you can get? Let's see. 2 to the power of 24. You see, almost 16 million IP address. Means you can give this IP address starting with 10 to 16 million network. Device. 16 million device. If you want to talk to all 16 million at the same time, just in one packet, all should receive the packet. In that case, you can use this broadcast IP. Broadcast IP is an IP that can take your packet to everyone in that network. It will not take the packet to 11001 computer. It will take the packet to everyone that has got IP address beginning with 10, starting with 10. You see? So this is class A, isn't it? Now tell me, what is the default subnet mask? I know. Yes.
255.0.0.
Excellent. Because it is class A. Santosh, what is the first IP in that subnet? Correct. Now, why it is not 10.1.0.0? Because whenever you want to consider host, it should start from this end, not from this end. But whenever you think about networking, enlarging networking, subnetting, then you should not take bits from here. For networking, you should take bits from left-hand side. For networking, it should go from left to right. For the host, it should grow from right to left. Now, first IP, as Santosh said, it is 10.0.0.1. Now, what will be the broadcast IP, you know? When all the host bits are on. When all the bits are on here, what is the value? 10.255.255.255. This is the broadcast address for 10 network. You see, I want to say something before we go to the last IP. This 255.255.255.255 is also a broadcast address, layer 3 broadcast address. This will take the packet to everyone in the internet. It's a global broadcast address. It's not a broadcast address for 10 network. But this is a broadcast address only for 10 network. So all those who are in 10 network alone will receive the packet if you send the packet to this address. To this address. But when you send this packet to this address, not only someone in the 10, even someone in a 122 network will receive. Someone in 192 network will receive. So this is a global broadcast address. It's for the entire network, regardless of A, B, C classes or any network. This is also a broadcast address, but this is not a broadcast address only for 10. This is a broadcast address only for 10. Now, one less than this is what last IP, 10.255.255.254. This is the last IP of the computer, of the network. This is the last IP address someone will give to the computer in this network. See, this is not subnetting. This is without subnetting, first IP, last IP, broadcast IP. We will be learning subnetting shortly. In each subnet, you will have a separate first IP, last IP, and broadcast IP. Okay. Now you see, in an organization, you got many departments. If for the whole company department, if you have only one broadcast address, how will you be able to talk to all the members of sales? Think. If you want to talk to only the sales group, you don't have a broadcast address. Why? You didn't do subnetting. For the entire company, you got 10 network without subnetting, and you got only one address. You just got only one address. So the broadcast IP, when someone says broadcast IP, you need to be careful. Are they talking about the global broadcast address or the broadcast address of a particular network? I was telling you, when you do subnetting, for each subnet you will get a dedicated first IP, dedicated broadcast IP, dedicated last IP. For example, earlier I was doing a simple subnetting 10.0.0.0, 10.1.0.0, 10.2.0.0. For all this, what is the subnet mask? 255.255.00, 255.255.00, 255.255.00. So now you know, for this, the first IP is 10.0.0.1. These two look same, but it is not same. Why? The mask is 10.0. This is just a 10. This IP and that IP is not same. Computer will know very well that these two are not same based on the subnet mask that you put after the IP address. That's why we put subnet mask whenever you put IP address to a computer. Now, if this is the first IP, then what will be our last IP? Last IP will be this 10.0.255.255. Look at this. It's not same. Why it is 10.0? Because it is masked. Now, what will be the last one? 10.0.255.254. Because it is masked, it will always remain 10.0. Now, in the second subnet, it is 10.1.0.1, 10.1.255.255 is the broadcast, 10.1.255.254. You see, for each department, you got a separate, dedicated, different first IP, last IP, and a dedicated broadcast address. Now, if this is given to sales, if this is given to the admin group, now if I want to talk to admin group all admin group, I'll use this address. If I want to talk to all the salespeople, I'll use this address. When I talk to salespeople, no admin group members can receive my packet because I got two different broadcast addresses. These are all the advantage of subnetting. You see, you got isolation between one department and the other when you do subnetting. Now let's go back to our exercise that we were doing. One 90.0.0.0. What class it is? Santosh? Excellent. Mask is
Class D,
255,
sir.
255.0.0. So what will be the first IP? 10, 190 to 190.0.0.1. The broadcast will be, you see, it is masked. So they should not become any other number other than 0. 190.0, 255.255. And the last will be 190.0, 255.254. Right? So we got classes, first IP for each network, last IP broadcast IP. Let's take two more examples, then we will get into subnetting. Okay, let me say 200.1.0.0. What class it is? What class it is? Excellent. Class C. And the mask
Class
is
D, sir.
255.255.255.0. So the first IP will be 200.1.0.1 and the broadcast will be 200.1.0. You see, it is masked. So you should not change the 0 as any other number.
It is masked.
And the
So you
last
should not
IP
change
is
the 0 as any other number.
200.1.0.254. Next, just one more exercise like this, then we'll get into subnetting. You know this is class B and this is the mask. And what will be the first IP? 0.1, isn't it? The last IP will be the broadcast will be this. The last will be that's it.
1:50.
So this part is over. You can understand here from this that each network will have a first IP, and there are many middle IPs, and then there will be a last IP, and there will be a broadcast. Now let us move on to understanding an octet. If you take an IP address, there are 4 octets. What is octet? 8 bits. 8 bits. 8 bits each. There are 4 octets. 8 bit each. 4 octets. Now, if you understand one octet, it's the same rule for other octets because all are 8 bits. So let us take just one octet and try understanding. 1, 2, 3, 4, 5, 6, 7, 8. Because it is binary, we will say 2 raised to 0. Because it is binary, why should it be 2 raised to 0? If you ask that question, again the answer will be something which you don't understand, only they will give. They will say, hey, it's binary, man. There is only two number, 0 and 1. So it is 2. I got into more confusion. What? 2? 2 raised to 0? Binary? 0 and 1? Still I didn't understand. Later days, I came to know like this. So if you are also like me, you will understand now. Why should be 2 raised to 0? Why not something else? Because it is binary, why it should be 2 raised to 0? So to teach this one, if my teacher would have taken from something which I already know, I would have understood this. But they did not do like that. Maybe the teacher didn't have time. When I ask, why should it be 2 raised to 0 if it is binary? No, Jay, it is 0 and 1, so 2. Still, I didn't understand. So, later days, when I was grown up, somewhere around 30 or no, 28 years old, that's the time I saw somewhere written like this. You see, for decimal, it is 10 raised to 0. 2024. This place is 10 raised to 0. This place is 10 raised to 1. This place is 10 raised to 2. This place is 10 raised to 3. Any number raised to 0 is 1. 1 multiplied by 4 is 4. 10 raised to 1 is 10. 10 multiplied by 2 is 20. 10 raised to 2 is 100. 100 multiplied by 0 is 0. Next, 10 raised to 3 is 1000. 1000 multiplied by 2 to 2 is 2000. Now you add 4, 2, 0, 2024. Wow, same number. Now I understood a little bit, but still not clear. How can 2 raised to 0 binary? Why should I write 2 raised to 0 for binary? Then I understand further reading. It said, hey, look, you know how you got this 10? When you put 10 only, you get that 2024. You just converted by adding the face value. But why did you put 10? It is only 10 number. Decimal number system is what we are following. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There is no more fresh number. If someone wants to write 10, there is no fresh number. They take this one and they take this one and they make this number out of the existing number. So the fresh numbers are only 10. That is why you put what? 10 raised to 0. Likewise, in binary, you got 0 and you got 1. There is no more fresh number. 0 in decimal, this is binary. 1 in binary is 1 in decimal. But in decimal we have 2. How do you write in binary? 1, 0. See, it is made out of these two numbers. It's not a fresh number. So we make big numbers just by using these two numbers. So you have to put 2 raised to 0. In school, when they were teaching in 6th standard, 10 raised to 0, 10 raised to 1, you agreed. Now you also need to agree this. There we say 10 raised to 0 because it is decimal. Our poor 6th standard teacher did not have that patience to teach proper, so we did not understand that part, so this part became difficult for me. Why it is 2 raised to 0? It was a big question on those days. But later I learned it. So binary, it's 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, 2 raised to 7. Actually 8-bit, why it is 7? Because you are starting from 0. Okay. Now if this all bits are 1, now what will be the decimal value of this places? 2 to the power of 0 is, I told you anything power 0 is 1. 1 multiplied by 1 is 1. 2 to the power of 1 is 2. 2 multiplied by 1 is 2. 2 to the power of 2 is 4. 4 multiplied by 1 is 4. 2 to the power of 3 is 8. 8 multiplied by 1 is 8. 2 to the power of 4 is 16. How do I get 16? 2 into 2 into 2 into 2. 2 to the 4, 4 to the 8, 8 to the 16. 16 multiplied by 1 is 16. 2 to the power of 5 is 32. 32 multiplied by 1 is 32. Likewise, 2 to the power of 6 is 64. 2 to the power of 7 is 128. So this is what called as the place values in decimal. Now when you add all these, you get 255. When you add all this, we get 255. See, writing IP address in binary is very difficult. That's why we convert into decimal and we use. That's why I converted in decimal and I have added all this and I'm giving you the sum of all this. So you should not forget this one thing. What? If all the 8 bits are on, it is 255. Secondly, if it is 1 and all the rest of the bits are 0, what is the value? 128. Because only this bit is on. Other bits are off. So if you multiply 64 by 0, what you will get? 0. If you multiply this 32 with 0, what you will get? 0. You see? So when only one bit is on, it is 128. Don't forget. If that 8th bit is on, 128. Don't forget. This is very important. So that you don't need to every time add, calculate. Next. If the first 2 bits are on, what is the value? See, if all the bits are on, I added all this and I got 255. If just the first 2 bits are on, what is the value? No, you should add and tell.
64.
192.
No,
Do not forget.
192.
If the first 2 bits are, kindly mute because I'm getting echo. When you want to talk, please unmute. Thank you. So when the first 2 bits are on, you don't need to calculate every time. If you remember 128 plus 64, don't keep adding every time because you are not going to deal with more than 8 bits. So better remember these things. If the first bit is on, it is only 128. If the first 2 bits are on, it is only 192. Next. In that 8 bit, if the first 3 bits are on, what is the value? 128 plus 64 plus 32. What is the value? It is 224. Yeah. And
224.
remembering this number is also easy. If you see
224.
here, it is doubling. 1, 2, 2 is doubled, 4, 4 is doubled, 8, 8 is doubled, 16, all double. Doubling. Next, don't keep adding every time. When you see 3-bit, you should immediately say 224. If the first 4 bits are on, now it is another 16-bit. You need to add another 16-bit to this. Exactly. Now, what's this?
40.
To calculate this 240, there is also another way. If you see these 4 bits are on, it is 15. You know how? 8 plus 4 plus 2 plus 1. So 255 minus 15 is what? These are all 0. So 255 minus 15 is what? 240. Why should I subtract by 15? Because those 4 bits are 0. So either you can add 128 plus 64 plus 32 or 16, and or you can also subtract. See the zeros and subtract those face values from the total 255. Total is 255, and the face values of these 4 are 15. So I subtracted that 15, I get 240. Okay, if you remember these things, it will be easy for you to calculate. Now I'm going to test you whether you got this. Can I ask you some question? Are you ready? Right.
Yes, sir.
1 1
Right.
0 0 0 0 1 1. What is the value? You know this one is 192, right? This is 2, this is 1. What is the value? 195. You got it? Shall I ask you another one? This 192 is because 128 plus 64.
Yes.
Okay, next.
This 192 is because 128 plus. Okay. Next.
What is the value? Exactly.
225. Exactly.
What is the value? See, I told you when all these are on, 15. 15 minus 1. 14.
See, I told you when all these are
So that's
on,
what happened.
15. 15 minus 1.
Shall I ask you another one?
Yes, sir. Yes, sir. Yes, sir.
Okay. Exactly. Super. Fine. Now it's
197.
the right time to get into submitting, but I'm not going to do that today.